Question 47. Let r and theta be the polar coordinates defined by, this is a very standard definition of transformation between the Cartesian coordinate and the polar coordinate. X is equal to r cos theta and y is equal to r sin theta. We have to find out the area of the cardioid. The function is given right here, and it's in the range of 0 less than equal to theta less than equal to 2 pi. So this is, of course, theta is equal to 0, this is pi by 2, this is pi, and this is, of course, 3 pi by 2, and that's 2 pi, right? So in this is a closed curve, and of course this is x is equal to r cos theta and y is equal to r sin theta. Now this is a very standard definition of the area of the curve. This is given by area is equal to half of into alpha to beta r squared d theta in the range of alpha less than equal to theta less than equal to beta. So this is equal to, alpha is equal to 0 here and beta is equal to 2 pi in our case. So here this would be equal to half, this is equal to 0, and that's equal to 2 pi r squared d theta. But before we find out the area, just very quickly let's see how the function looks like. Here let's look at theta is equal to 0, or it could be theta is equal to 2 pi at this point. See if that satisfies the equation or not. At theta is equal to 0, r is equal to a minus cosine of 0, and this of course equal to 1. So a r is equal to 0, and therefore x is equal to 0 and y is equal to 0. So at this point here, this is equal to 0 comma 0. Okay, at theta is equal to pi by 2, which is right here, r is equal to a 1 minus cosine of pi by 2, and that of course is equal to 0, and then we therefore get this equal to 1, and x is equal to r cosine of pi by 2, and that of course cosine pi by 2 is equal to 0, so that is 0, and sine pi by 2, so that's equal to a. So here at pi by 2, here the values are 0 and a. So this is the value of 0 and this is equal to a on the y scale. Okay. Let's look at theta is equal to pi, which is right here. R is equal to a 1 minus cosine of pi, and in the cosine of pi in this quadrant it's going to be equal to negative of 1. So this is 2a, and x is equal to r cosine of 2a cosine of pi, so this is of negative of twice a, negative 1, okay, and sine of pi, so that's equal to 0. So this is going to be equal to negative of 2a and 0. So at this point here, this is theta is equal to pi, and this is equal to negative of a, and this is negative of 2a. So this value is negative of 2a, and y is of course equal to 0. So that also matches. And lastly, look at this point here, 3 pi by 2. That's a value here, 3 pi by 2. Similarly, r is equal to cosine of 3 pi by 2. You can see this is a value of a, and that of course equal to here. This is going to be equal to 0, and this is going to be equal to a, and here x is equal to 0 and y is equal to negative of a. Okay. A cosine of 3 pi over 2, cosine of 3 pi by 2 in this quadrant, this is going to be negative of 1. So this is going to be, so this is equal to 0, and this is sine 3 pi over 2, which is equal to negative of 1. So this is equal to negative of a. So this is at theta is equal to 3 pi by 2, this x is equal to 0, and y is equal to minus a. So this looks okay. So that's my, of course, the cardioid. This matches this function right here perfectly. So now next part is very easy. We have to find out the area. Easy as long as we know that the area is defined by this particular equation here. So here we have to write this is equal to 0. Here of course alpha is equal to 0 and beta is equal to 2 pi here, r squared d theta, and we put since this is a symmetric curve here, so this quadrant and this quadrant are symmetric, we can write in terms of area, we can say half into twice of, if I just use it from 0 to pi. From 0 to pi, we find out the area and multiply that by 2, and that gives me the total area. So that's what it is. And here this is, of course, we just put r is equal to a into 1 minus sine theta here. And if we do the integration, the details of the integration is shown in the website here. It becomes 3 pi a square over 2. So A is the correct option.